Hello, those students, and welcome to your physics lesson. In today's lesson, we're looking at magnetism. This is our first lesson in magnetism, so we're going to be looking at the basic principles of magnetism, principles that should always carry throughout this topic, magnetism. The first thing we're going to look at is what a magnet is. Magnets will be referred to many times when we're looking at magnetism. So, what are magnets? Magnets can be said to pieces of material that attract materials containing iron or simply materials that portray properties of iron. Meaning sometimes these materials might not even contain iron, but they'll be attracted by a magnet. However, this lengthy definition can be simply said as a magnet is a piece of material that attracts magnetic materials. To get an understanding of the word magnetic material, watch this video till the end where we compare what magnetic materials are and what non-magnetic materials are. For now, let's look at the different types of magnets that you should know. The first one is the bar magnet. The bar magnet is very common under the topic magnetism. You'll see why. It's referred to as simple and it's just a bar. Another type of magnet you need to know is a horseshoe magnet, which has the shape of the shoe of a horse. The other third type is a ring magnet, which is just in a form of a ring as shown in the picture. Such magnets can be found in devices like speakers, the magnets that are behind the speaker and are very essential in producing the sound. These can also be found in microphones. However, above all, you should know these three magnets. If you are told to draw a horseshoe magnet, you should draw that magnet that has been shown and indicated as horseshoe. With that said and done, now let's look at properties of a magnet. Magnets have got properties, and these properties should be known to you. The first one is that magnets will have two sides of it where the most force will be found to be concentrated at. These these ends are known as poles, and usually magnets have got two poles, the north pole and the south pole. In the diagram here, we've got a bar magnet which has been labeled north and south pole. You can see the notation for north pole is a capital letter N, and for south pole it's a capital letter S. This is very essential to note. And in experiments to prove this property, a bar magnet is gotten and dipped into a magnetic material like iron filings. And after that is done, what happens is that those small pieces of iron are seen to be more on these pores. They are not so much around this area, but so much around this area and this area. Another property is that when a magnet is suspended freely in the air, such that it can rotate without any obstruction, what happens is that the north pole of the magnet aligns itself with the north pole of the earth. Why is it like this? Well, some say that this is because like the earth has got a big bar magnet in its inside that is a bit inverted. So at the north pole we've got a south pole, and at the south pole we've got a north pole. And this brings us to the law of magnetism, which should stick into your mind. This law is very essential and affects how magnets move or basically attract and repel. This law simply states that poles which are unlike will attract to each other, while poles which are alike or which are the same will repel each other. Attraction is just two magnets coming together and sticking together, while repulsion or repelling is the action of two magnets not wanting to come together even if they are forced to come together. In diagrams, it might be shown like this. When you get two poles which are not the same, like in this diagram on top, the two magnets which have got unlike poles will come together, and even without pushing them together, they'll come together. However, for these other magnets which have got the same or like poles, even with a force bringing them together, they'll be exerting opposite forces against each other. So one will be pushing the other magnet away from each other. If you've got two bar magnets, you can try this out. With that said, now let's look at magnetic and non-magnetic materials, which we said will be looked at the end of this lesson. Magnetic materials are very simple. These are materials that have the ability to be attracted by a magnet. So materials such as iron and ferromagnetic materials are magnetic materials. And this is because they can be magnetized and demagnetized. Don't worry about these two ways that have been introduced, magnetized and demagnetized. For now, understand that magnetic materials are materials that can be magnetized and demagnetized. These are the materials that can be attracted to a magnet. Examples include iron, cobalt, and nickel. On the other hand, we've got these non-magnetic materials. If magnetic materials can be magnetized, meaning non-magnetic materials cannot be magnetized or demagnetized. And therefore, that's what they are. Materials that cannot be magnetized and demagnetized. For example, rubber, copper, and plastic. If you can see under the heading non-magnetic materials, we've got the metal copper. This is why it's not very wise to define a magnet as a piece of material that attracts metals, because not all metals that are in our world earth can be attracted to a magnet. Some are not. Some metals don't just get attracted by a magnet. So this is why it's very useful to use the word magnetic materials, like I said at the start of this lesson. And so to get the meaning of these two words that we've encountered here, magnetized and demagnetized, it's very good of you to look out for our next physics lesson. We'll be looking at how we can magnetize something and how we can demagnetize something. Thanks for watching today's video.